Unit 3, Day 1 Notes. Today we're going to be talking about parallel and perpendicular lines. Before we begin, we need to make sure we remember slope. Slope, again, is your rise over your run. Why isn't my pen cooperating? And we represent slope with the letter M. So again, it's rise over run. So you have to read from left to right, and to get from point to point, you would have to go down 1, 2, 3, 4. So that's a negative thing because you're going down, and you're going to the right. 1, 2, 3, 4, 5, 6, 7, 8. So that's a positive thing. So you put rise over your run. So that means negative 4 over 8. And if it can be reduced, you need to reduce it. And when you reduce it, it would be negative 1 over 2 as a final answer. On number 2, same idea. Again, you got to count from point to point. Read from left to right. So as I go from left to right, I go up. 1, 2, 3, 4, 5, 6. So that's a positive thing. And I go over to the right, 2. So that's also a positive thing. So again, you put your rise over your run. So that's 6 over 2. And can it be reduced? Yes, it can. It would be simply 3 over 1 or 3. Now, given a graph, it's nice. You can simply count your rise over your run, as I illustrated before. But if you're not given a graph, there's a slope formula, which tells you to take your y2 minus your y1 over your x2 minus your x1. So the first thing I would do, given a set of ordered pairs like I am in number 3 and 4, is label my x's and my y's. You can choose to label them however you feel. So let's say this is x1, this is y1. So if that's the case, that means this would be x2 and y2. Make sure ones go with ones and twos go with twos. And if you keep it like that, you should be fine. And then it doesn't matter which ones you call x1, y1. I could have labeled it the other way around. That doesn't matter. But as long as your ones go with your ones. So write the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm going to set up the skeleton. My minuses are part of my skeleton, as well as the fraction bar. And now I insert the numbers in their appropriate locations. So I said y sub 2 was 11, y sub 1 was 6, x sub 2 was 7, x sub 1 was 5. And now you can subtract 11 or 6 from 11, you would get 5. If you subtract 5 from 7, you would get 2. And leave it as a fraction, and this is my final answer, 5 over 2. It can't be reduced, so I'll leave it as is. For number 4, again, start with the formula every single time. Y sub 2 minus y sub 1. Write it every time. That way you won't forget it. And yes, the subs do matter when you write this formula. Now label your coordinates. So this would be x sub 1, y sub 1, x sub 2, y sub 2. Lay out your skeleton. The minus, the fraction bar, and the minus, they have to be there no matter what. Now you can insert the values where they belong. Y sub 2 is 2. sorry, negative 2. Y sub 1 is positive 2. X sub 2 is 6. X sub 1 is negative 6. Make it a habit to put the negative numbers in parentheses after operations. I could have done negative 2 in parentheses at the top, but it came in front of the subtraction, so it wasn't that crucial. But if you want to, just put all negative numbers in parentheses, which is totally fine. Now, if I owe somebody $2 and then I borrow another $2 from them, that means I owe them $4. So negative 2 minus 2 is negative 4. I owe them $4. Anytime you have a double negative situation, like 6 minus negative 6, you got to remember that that minus becomes a plus and that negative becomes a positive. Anytime there's a double negative like that. So you would have 6 plus 6, which is 12. So now I have negative 4 over 12, and I can reduce that to simply negative 1 over 3. And that's my final answer. Please practice these 4 on your own, and definitely take a picture of these 4. Now let's talk about slope-intercept form. Slope-intercept form is y equals mx plus b. You should remember that from algebra. But if you forgot, number 9 wants us to write the equation of a line with the slope negative 2 and a y-intercept of b. So again, when you have slope-intercept form, the reason it's called slope-intercept form is because, again, m is your slope, and b is your y-intercept. So on number 9, when they want us to write the equation, and we're going to write it in slope-intercept form, let's first write out y equals mx plus b. They tell us the slope is negative 2, so that means negative 2 is m. They tell us the y-intercept is 4, so that means 4 is b. So I'm going to substitute those into their appropriate spots. I'm not going to substitute y with anything. M, so I'm going to substitute m and b. So m is negative 2, b is 4, and then now the final equation would read y equals negative 2x plus 4. And that's all they wanted us to do. Write the equation in slope-intercept form. Number 10, write the equation of the line with the slope 4 over 3 and passes through the point 0, negative 7. So m is 4 over 3. When you see a coordinate that has an x value of 0, anytime you have a coordinate with an x value of 0, that is a y-intercept. So this is b. So write down the format, y equals mx plus b. Fill out the skeleton. And then insert the values where they belong. Our slope, or our m, is 4 over 3. Our b is negative 7. You only need the y value. That's it. And now write the equation nice and neat. So it would be y equals 4 over 3x minus 7 as a final answer. All right, number 11 is slightly different. It says write the equation of a line with the slope of negative 2 over 5 and passes through the point 10, 1. So 10, 1 is not your y-intercept. we're going to have to find b in this situation. We're going to have to find b. So this is how the process will work for this type of situation. Negative 2 over 5, that is m. But we're going to use the point that they give us as x and y. So again, write down the basic format. Y equals mx plus b. Write out everything we have. We have everything except for b. So substitute where they belong. So y is 1, m is negative 2 over 5, and x is 10. So bring down your 1, multiply negative 2 over 5 with 10. I'm going to do this without a calculator, but you're welcome to use a calculator if you need it. This would give me a negative 20 over 5, which is a negative 4. And bring down your plus b. So to get b by itself, what would I have to do? Exactly, I would have to add 4 to both sides. So that means 5 is equal to b. Now that you have b and you have your slope, you write out your equation in y equals mx plus b form. Again, write out the skeleton. Y equals mx plus b. Y will stay in its place. You're only replacing m and b. So m was negative 2 over 5, and b is 5. So the final equation would read y equals negative 2 over 5, x plus 5. Now we get into parallel versus perpendicular. What you need to remember is that parallel lines will have the same slope. Parallel, same. Also to remember that parallel lines never ever intersect. Never ever. In other words, they'll never cross. So when you graph two parallel lines, you would have two lines essentially as follows. Never ever touching to infinity and beyond. When you write the equation again, make sure that the slope is identical. Like in our examples here, y equals 4x plus 5 and y equals 4x minus 12. So the slope has to be the same. The y-intercept, however, must be different. Now when it comes to perpendicular, you're looking for opposite reciprocals. Sometimes that word is hard to remember, so that's why sometimes you need to take it in stages. So in the first example, we have our first slope, this is m1, is equal to 2/3. To convert it to the opposite reciprocal, the first thing I would do is write the opposite of 2/3. So the opposite would be negative 2/3. And then you write the reciprocal of that. Reciprocal means to flip it around or flip it over. So the reciprocal of negative 2/3 is negative 3/2. So that is an opposite reciprocal. So that's why M2 is written as it should. So again, it's hard to make that connection, but you can do it in stages. First, do the opposite. and then flip it. And that's exactly what happens. So that is why it is -3/2. If the slope for M1 was 3, you would make it the opposite by making it -3, and then you would flip it by making it -1/3. So that's why -1/3 is an opposite reciprocal. Another thing to remember about perpendicular lines is that they do cross. Yes, they do. They do cross. And when they cross, they form a 90-degree angle at the intersection. Every pair of perpendicular lines must form a 90-degree angle at the intersection. So all of these angles, all 4 of them, are 90 degrees. And this concludes our notes for today. Thank you for your attention.